So this is section 7.7. See, exponential and natural logarithmic function. So let us say it can be shown that for the exponential function y equal to ex. See, so e raised to the power x is the variable, right, and e is the constant, right? And now we want to differentiate this function with, y with respect to x, right? So the variable x is in the exponent. So what can we do? We have shown to you that if this is an exponential function, then the result will be ex itself, right? Okay. Now, so that is one thing. So more generally, we can write the rule as shown below. Look at that. Y equal to A is some constant multiplied by EMX. X is the variable, M is some other constant. See? And if we now differentiate, the result will be M, this constant here, multiplied by this constant here, and then the EMX, right? So this part exponent, whenever we are differentiating, dealing with the exponential function, that e and whatever the exponent is will not change. That will get multiplied. So let us take a look at this problem, right? Find dy dx, right? And then when the function is what? Y equal to 7e, you see minus 3x, right? So if we choose, like as we have done before with this example, so remember before we said y like this, right? We cannot, so let us see, y equal to what? Y equal to AEMX. See that? And we said that if we differentiate this with x, we will be left with what? MAEMX, right? Okay. Now what happens? Now this is M equal to what? Okay. Now what happens? Here we have A, and here we have M, right? So if we follow the formula, m, that minus 3 will be multiplied with that a7, and then e raised to the power minus 3 remains unchanged. And if we now solve further, this is the result we get, right? Okay. Now let us take a look at this figure 7.4, right, from your textbook Gene Soper, right? Soper's book. And this book is what? So we are now talking about log. Look at that. Y equal to log e of x, right? Yeah, let me check. Isn't it 7? Yeah, log e of x, right? And then if we differentiate, it will be dy dx. If we want to get that, differentiate log x, we get 1 over x, which we can write it as x raised to the power minus 1. See, now more generally, if we have y equal to log emx, right? Please friend, that looks like c, but that is actually log, yeah. And then what? So let us differentiate. If we do, it will be 1 over x, right? 1 over x, and then equal to this one, right? And then so having m in multiplied to that x will not have an effect. But what about, and if we have this, a multiplied in front of x and then x raised to the power m, then what is going to happen? If in that case, if we take log, it will be m multiplied by m divided by x, right? Okay. Okay, now we want to solve this problem. This problem on page 264 on the SOPR book. And now they are telling us that they give us this function p equal to minus 80 log of q divided by q plus 2. See, and they ask us to find out this dp over dq. So what are we going to do? Well, several things we are going to do. First thing, we are going to simplify this one. So you see, q divided by q plus 2, let us make it w. Make it simple, right? Then the entire thing will become what? Minus 80 and then log of w. See that? Entire, so here, so that one. And now the next thing we want to do is that when we make it w, then to find dw over dq, we now have to use the what? We see that w equal to all of this. So now from here we want to find out dw over dq. We can use the quotient rule here, where u, the upper function, this is 1, and the lower function v is this 2, right? So now let us use the quotient formula. We have v, the lower function, multiplied by this derivative, right, minus u, the u is the upper function multiplied by the derivative of the lower function, and then the lower function v squared in the denominator. So that is what we have done here, right? So when we differentiate this u with q, let us say u with q is just q, so it's just 1, and v is q plus 2. See, we put this here. On the other hand, in the next phase, u is this, right? U, and then we differentiate this one with q and q, and we just get 1 here, this one. So we simplify, we get this. This is the result of dw over dq. Now let us see, substituting w, p equal to, so as we said here, right? So that is here. Now let us differentiate p with respect to w. So we have minus 80, that log of w becomes 1 over w, right? 1 over w. Now this w we have to replace. So let us replace this one w. Remember we said this number 1. So let us put it here and then simplify, we get this, right? Now we are going to use the chain rule and substitute for w. Uh, so chain rule is delta p over delta q. This is what we are looking for, see? And then delta p over delta w is which one? This one. We know. So we substitute all of that. See that? And then what about multiply by delta by dw over dq? dw over dq is all of this. You see that? Here, this. So that is the second part. And then we combine, simplify. This is the result. This is the result we get, right? Okay. This end these problems, right? So look at that. Y equal to 10 e raised to the power 4x, and now we want to solve it, right? We want to differentiate with respect this y functions with respect to x. So let us see. So here what can we say? So y equal to what? 10e minus 4x, right? So here when we differentiate with x, we know that this nothing will happen to that constant term, and that e raised to the power minus 4x, that minus 4 will come in front and get multiplied. The e minus 4x will remain unchanged. See, so minus 4 times 10 is actually minus 40. E minus 4x, that will be that e minus the minus 4x, that will be the answer, right? So this is number 1. Number b is what? Number b is what? Y equal to x e to x, right? So we have two things here, and we want to differentiate with x. We can use the product rule. See, So we can say that u is equal to x and v is equal to what? E to x, right? And let us see. So using product rule, so product rule is what? We know that this is so this is u times v. So in the product rule we have v differentiate u with x, right? And then multiply, add, this is u, and then this is what? Differentiate v with x. See that? So we can, so let us see. V is e raised to the power 2x, right? Yeah. So now let us differentiate this. If we differentiate u with x, this becomes 1. If you differentiate that v with x, it becomes what? 2e to x, right? So look at the, check the formula, that one will come, that 2, yeah, okay. So yes, so now, so we have, so let us now substitute the values also here. This is what? From here, number 1 and this one, see? So this is 1 plus, what about u is, we are saying, is equal to x, right? And then multiply with this 2e to x. So let us then simplify e to x times 1 is just e to x, and this will be 2x e to x, see? So that will be the answer using the, you're using the product rule, see? Okay, now what about this one? What can we do about this part, the part C? Let us see if we can make some room here. So this is page 2. This is actually, now since we are here, this is page 269. 269. See? So what the problem we are about to solve? So what is the problem? The question is asking us what? Just a minute, please. Hold on. Bear with me. Okay. Okay. So now what are we doing? So we are. So let us write down the function. So this we are solving for 710, not this one. And this is page 264, right? We solve a and b of this, and now we want to solve c. So y function is given as what? Log of e and then what? 3x minus x square, right? And now what do we want to do? We now want to differentiate this one. We now want to get dy over dx, right? So how are we going to do that? So let us say that we make all of this. So we will do it in two parts. Let us say that this one we make as like u, right? So u is equal to what? 3x minus x squared. So let us differentiate with respect to x. So this is 3 minus 2x, right? Okay, differentiate with respect to x. And now what happens? And then if we make it like u, so 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 y equal to log eu. See, Now differentiate this one with respect to u. U is, it will be what? It will be 1 over u. So now for this, to get this, let us multiply. Let us use the chain rule. So dy over dx du, right? Here du, and this is du over what? Dx. So this will be what? 1 over u, and this du over dx is what? Minus 3 minus 2x, and then let us substitute back the value of u from here, right? So it will be 3 minus 2x, and then what? U is what? 3x minus x squared dy over dx. So this one, this should be the answer. Yeah. Why do we have just that? I'm thinking, did we pick it up wrong? Oh, this was 30x. See, 30x. This was not 3x. 30x. So all of this, put 30, 30, 30, 30. See, all of that. So now this is the answer. So sorry, I made a mistake. I picked up the wrong number, not 3. It's not 3. It should be 30. Okay. So thank you. Thank you for watching.